Okay, let's insert our workpiece here. I've got a 1/2 inch collet. What? Why did I think this is 1/2 inch? Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to show you the very basics of making your own cutting tools with a D-bit grinder. Now I am far from an expert on this machine, and there are lots of different ways to use these machines, and these machines are all a little different. I have 12 different manuals for different versions of a D-bit grinder, and all of them have different procedures with the same basic controls for making cutters. So I'm going to show you what has worked for me for making the most basic form of D-bit, and we'll go from there. Okay, let's go. What's a D-bit grinder? It's one of these. All right, video over. Good show, everyone. I'm just kidding. There's a lot more to talk about. A D-bit grinder is kind of a specialized, or simplified, I should say, form of tool and cutter grinder. So it's got a spinning grinding wheel here, in this case a diamond cup wheel. You might have an aluminum oxide cup wheel on there. You might also have a cutoff wheel or straight wheels of various types. And then there's a very elaborate workhead here which has a lot of adjustments for holding a tool relative to the grinding wheel in very precise and repeatable ways. Now the official raison d'etre of the D-bit grinder is right there in the name. It's for grinding D-bits. What's a D-bit? Well, contrary to what many internet commenters would have you believe, there is not exactly one name for everything in machining. And funny how that name always seems to correspond to the thing that they call the thing. But that name D-bit refers to different types of things and different types of trades and different types of machining. But in this case, I'm referring to this form of single flute cutter. So this is a piece of carbide that's been split in half, and then a shape ground into the end of it here to form a single flute cutter. And this is the most basic thing that the D-bit grinder does. And so if you want to learn how to use a D-bit grinder, you better learn how to make these guys first. And what kind of cut does this guy actually make? Well, this is an end mill. Now, it doesn't look like one because it's a single flute cutter, not something you're typically used to. It doesn't have spiral flutes or multiple cutting edges, but it is an end mill. And in fact, it made these cuts that you see here. Now, where these guys really shine is if you need a very specific nose radius in the bottom of a slot, or if you need a very specific angle on a V-groove, or specialty forming and shaping operations like that. You can very quickly and easily grind a single flute cutter to do exactly the type of operation that you need. But it's actually pretty useful for a lot of other types of grinding operations in the shop. You can coax it into regrinding end mills and making lathe tools and making engraver bits and various specialty end mills, and just about any single flute cutter you might want to make. To start with, you're going to need stock. Now you can buy dedicated stock for D-bit grinding from McMaster Carr, for example, is where I got this. But you can also just use any old dull or broken cutters that you have lying around. Anything carbide or high-speed steel will work for you. So you can just take an old broken center drill or end mill or whatever, lop the end off, or grind the end into the shape you want, and Bob's your uncle. Now, if you do want to start with fresh stock, such as I've been using here, I recommend buying something like this from McMaster or similar outlets. This is a piece of solid carbide, and it has split ends. And you really want to buy the split stock, because otherwise, if you buy the solid round stock, the first thing you have to do is cut this split, and that's a lot of grinding on your expensive diamond wheels. Let's look at the basic controls, and there are a lot of them on a D-bit grinder, which can be a little bit intimidating, but it starts to make a lot of sense once you break it down into sections. So there are 2 pivots and 3 slides, and those give us all of our degrees of freedom. And most of those degrees of freedom have a coarse feed, a fine feed, and a lock. So all those degrees of freedom multiplied by 2 or 3 separate levers, and well, you got a mess of levers. Start with the most basic, and that's this bar right here. This bar is like the ways of the machine, and there's going to be a lock down here on the head which allows you to free this head up and slide it back and forth. So that's your coarse feed and your coarse rotation. Now, where it gets interesting is that the bar itself also has feed and tilt. So it's a bit like if this was the carriage on your lathe, this is your ways, except the ways can also move. So we do that with all of these controls over here. Now some of these details vary from D-bit grinder to D-bit grinder, but this is a Coolman SU2, and they're all going to be fairly similar to this. If you've got a Decal or one of the newer Asian clones, they're all going to be relatively similar to this. We have two locks here, a fine adjust here, and a micrometer adjust back here. This lever right here locks the tilting of the bar. So you can see that I moved the head, even though this right here is locked. So the head is not rotating on the bar itself is rotating. And then this right here is the fine feed for the rotation of the bar. So if I turn this guy, look at the head over here. See how the head is tilting? Now the way that you actually end up using this guy is as a stop, and that will make more sense here in a bit. Now this guy right here is the lock for the traversal of the bar. So in addition to this bar rotating, this bar also slides in and out, carrying the head with it. So once I unlock that, now I can move this micrometer. That work head is moving. Now this is a very, very fine feed. Each of these tick marks on here is 0.005. So this is a high precision way to move this bar and by extension move this head. So this is effectively the fine feed for the lateral movement of the workpiece. Up here on the work head now, we've got a main lower joint back there which rotates the head this way. And then we've also got this joint here which allows us to swing the head 90 degrees this way. These two pivots can do a million different things, but for the basic D-bit that we're going to grind, it's very simple. Imagine my cutter that I'm grinding is in the collet. It's my finger here, and the top of the cutting surface is my fingernail. You can see how this main pivot here tilts the cutting surface away from the grinding wheel, so that's creating the clearance behind the cutting edge. So what you're going to do is you're going to set it to 25 degrees, and you're just going to leave it there. Before we go any further, we got to talk about basic D-bit cutter geometry. It's a single flute cutter, so the split line, the halfway point of the cylinder, if you like, is the cutting edge. Now that clearance angle, that 25 degrees that we just looked at, is behind the cutting edge. That's this angle back here. So we have to be clearanced right behind the cutting edge, and that's what actually makes it a cutting edge, right? And then as this guy spins around, this whole area back here has to be a smaller diameter than the cutting edge. So the cutting edge is the full radius away from the center line of the cutter, but everything else is a smaller radius than that. So that as this guy spins, the cutting edge is engaging with the material, but nothing else is touching. And then this right here is the nose radius on the end of our cutter. Just like any other cutter on the lathe or on the mill, nose radius affects a lot of things. It affects surface finish and tool pressure and all of that. And then there's an end clearance angle at the end here so that as this mill is cutting, the end of it is not contacting the material. The geometry is very similar to a lathe tool. It's a single point cutter. So this nose radius right here is the business end. This is doing the cutting, and maybe some of this edge here, depending how deep you are. And then everything else here is just angles to get that material out of the way. So with that geometry in mind, we can look at that second joint now, which is this rotation. And for the basic D-bit, the purpose of this joint is to create that nose radius. Again, imagine my finger is the cutter that we're going to grind. You can see how rotating that guy 90 degrees is going to put a radius right on that front corner there up against the grinding wheel. Now the reason that you can clamp the head to the bar is that the bar then constrains the motion both laterally and tilting, and this tilting motion is your basic grinding motion. As you tilt it forward and back, you're moving in and out, and the grinding is happening on the face of that wheel. Okay, you know, just enough to be dangerous, so let's do some grinding. First you want to prepare the blank, and to do that you want to get some die cam on there all the way around the back especially, and on the end is helpful too, because it's going to be pretty difficult to see what you're doing unless you have some kind of reference. So the die cam on there really helps. The other two things that you really want in this procedure are magnification and light. If you're of a certain age, those two things are invaluable on the D-bit grinder because things are happening at a very small scale here, and it can be really difficult to see what you're doing if you don't have magnification, light, and die cam. Okay, we're ready to insert our workpiece here. This is a 1/4 inch blank, so I've got a 1/4 inch collet here, and I'm gonna wipe out my taper with a lint-free wipe here. This is a grinder, so everything's constantly covered in grinding dust. You wanna make sure that's not interfering. Just like any other collet system, there's a key, and then we've got a draw tube that we screw into the back, and then we slide our workpiece in here and snug that guy down. At this point, we need to understand this little guy. So there's this spring-loaded knob here, which has 3 positions. There's a short slot, a deep slot, and then you can put it between slots. When it's between slots, the workhead is free spinning, so you can do circular grinding with that. If it's in the deep slot, then it's locked, so that's the setting it was in so I could tighten the collet. And then if you put it in the short slot, then it will be locked to a specific range of rotation. And different D-bit grinders vary in this regard. The Coolman has 2 options for this. There's a 90-degree range and a 180-degree range. Some grinders only offer the 180-degree range, but generally for basic D-bit grinding, the 180-degree range is the only one that you're going to need. The next thing to set up is the range of grinding motion. Remember I said this is your basic motion, but you can see how it'll go in much too far and it'll go past the split line there that we have ground in, it'll hit the collet, it'll hit the workhead, etc. So we need to be able to set the limit so that this stops on each stroke exactly where we want. That's where this knob comes in here, but it can feel like that knob isn't really doing anything because nothing is stopping me, and you can turn this knob and nothing seems to happen. And so this setup can be a little confusing at first. The trick is that you need to rotate the bar up against the stop first. So this is sort of the coarse adjustment for rotation, if you like. So what I find helpful is to unlock the head and then just grab the bar and twist it until you hear it and feel it hit that stop. And now you can lock the head. And now when you're all the way in, now the end stop is having an effect. Then bring the workhead over close to the wheel. And then you can set this stop right where you want it. You can see that it hits my stop right there. And I'm using most of the split area here, but not all of it. You don't have to use the entire split area for your cutting edge. If you're starting with an unsplit blank, or maybe you've lopped the end off an old end mill or something, the first step is you need to split it. So we've set up everything you need to do that. It doesn't matter how the head is rotated or anything because this is still going to be round. So you set it up like this and you're all set up to grind your way to a flat spot. So how do you actually feed in for grinding? Well, that's what this guy right here is, the micrometer. So the workhead is locked to the bar. So this motion here is rotating the bar, not the head. And now when I rotate the micrometer, I'm cranking it very slowly towards the wheel. So you'll swipe in, do a pass, move in, half a thou, do a pass, half a thou, do a pass. So this is your motion for splitting that blank. And then check it with a micrometer periodically until you're exactly half, because remember that surface, that split surface is the cutting edge, and that needs to be on center so that when that thing is spinning, the cutting edge is on center, just like on a lathe. Okay, we're ready to start adding some geometry to this cutter. Now, the D-bit grinder makes some assumptions about the relative position of the flat surface of the cutting edge. And all of its geometry is configured assuming that the flat surface is in a particular orientation on this workhead. So it has some special tools to allow us to set that up. The first is the dot. So most D-bit grinders will have a little dot that appears, it's usually red, it appears in this little window back here. And that red dot is a magic orientation on the workhead. Alternatively, there might be a dot somewhere on the ring here. In this case, there's a dot right here that's a few degrees off of 90. And this, on this particular D-bit grinder, is the magic dot. That dot I showed you in the window means something different on the Coolman SU2 of this vintage. So this varies, again, by D-bit grinder. Most of them, it'll be a red dot in the window. In this case, it's a red dot on the ring. But the point is, to set up your cutter, you got to put the dot in the magic place. So either the dot in the window or the dot on the line here. And the second tool is this little alignment blade here. This little blade works together with the magic dot to get the flat of your tool aligned. So what you're going to do is you're going to put the dot in the window, or in my case, the dot on the line, and you're going to lock that workhead in that position. Then you're going to loosen the collet, and then you're going to take the stock and you're going to rotate it around. You're going to line it up with this little blade, like so. So when this little blade here is sitting flat on your workpiece, and then you can slide it back into the collet however you need to, so you got not too much stick out there, and then tighten your collet back down. This blank is now aligned correctly for where the machine is assuming it is for creating the rest of the geometry. So with the tool bit set up on the magic dot, now we can switch over to the indexing position once again. And there's our 180 degree motion. Notice that my cutting edge is not flat. It's not perpendicular to the grinding wheel. This is our clearance angle behind the cutting edge. That's what that first big joint that we set did. It tilted the entire workhead over so that when our cutting edge is where the machine thinks is straight up, it's actually leaned over 25 degrees. And now you can imagine as we grind this guy around through the 180 degree range, it's going to be grinding away the backside of the tool while leaving our cutting face on dimension and our cutting edge untouched. And we've gone a long ways here without ever actually turning the machine on, and that's how these machines are. You spend 20 minutes setting up a D-bit grinder, and then the grinding is done in about 8 seconds. There's 2 more things we got to do, and that's set these 2 slides. The workhead has a slide here and a slide here. The top slide is easy. You want to loosen your coarse feed and or lock, as depending on your machine, and then you're just going to slide this guy all the way back and lock it in. And then there's a little vernier scale here. This guy's also going to have a lock on it somewhere, and then there's going to be a knob somewhere over here in this case, and you can see that I can slide the head left and right a precise amount with this scale. But what is this slide actually doing? Well, picture if the tool bit is rotating exactly around the center of the cutting edge, then it's going to make a radius that is the same radius as the cutting edge. You're going to end up with a ball nose end mill effectively. So by sliding this further to the right, what we're doing is we're making that radius smaller and smaller. And for that reason, the scale here actually reads in reverse, as we'll see here. The math for setting that offset is really simple. You just take the radius of your blank, your cutter, and you subtract the corner radius that you want. I'm going to put a 40 thou nose radius on this tool, so we take 125 thou tool radius minus 40 thou, that gives us 85 thou. So we're going to set our vernier scale to 85 thou. If you only take away one thing from this video, make it this. You have to set your nose radius offset before you do any grinding, except splitting the blank. You can do that first if you want. But don't do anything else to your cutter until you set this scale. If you don't do this first, all of the geometry of the motion of this head gets all messed up, and nothing you do after this will work right. In my case, the large ticks up here are 50 thou and the small ticks are 5 thou. D-bit grinder's vernier is tricky because it's upside down and reads right to left, which makes a lot more sense from the operator position. So here's what I'm seeing on the final setting that I used. So you can see that I'm past the first major tick, so I'm at 50 plus, and then the 0, 1, 2, 3, 4, 5, 6, 7th tick is the best lined up one on the fine scale, which is the extra 35 thou. And don't forget to lock that slide so it doesn't move while we're grinding. And in my case, that's this little handle here, so snug that up. Now, if you don't have dust collection, you probably want to set some up, but if not, at least do this very, very far away from all of your machine tools. In this case, we're grinding carbide with diamond, and diamond dust is machine tool cancer. You don't want it anywhere near your machine tools. So yeah, definitely do this far away from anything that you care about. And I also recommend wearing at least a dust mask because you really, really don't want abrasive dust in your lungs. It's going to sit there for the rest of your life doing damage. The first operation is just to move in slowly with the head rotated all the way to the left until you start grinding away that die cam that we put on there, and you want to leave yourself just a little sliver of die cam on that cutting edge. And then without moving anything, just go back in and rotate it through the 180-degree arc, and it'll clearance the backside of that tool. Here's what it should look like at this stage. You can see I've got a little bit of die cam left on the cutting edge, and then a relief angle behind the cutting edge, and then the backside of the tool is all clearanced. If you accidentally go too far and remove all of that die cam, it may not be the end of the world, but it does mean that your cutter is going to be a little bit undersized. We leave that die cam on there just to make sure that we don't accidentally go too far and the cutting edge remains at the full diameter of the blank. Now we need to do the end clearance. So for that, we're going to loosen this joint here, and we're going to swing this guy through 90 degrees, and then we're going to lock it again. Now if we tried to grind it in this position, you can see we're too close to the wheel because of the angle that we're tilted downwards for our clearance on the end of the tool bit here. There's too much meat now interfering with the wheel. So now you want to zero this micrometer ring if you have a zeroing on there. I don't, so in my case I just make a note of that reading, and then I'm going to wind this back, and then I'm going to feed back into that number again with the same grinding feed motion. And again, until we have just a little sliver of blue showing on the end of that part. And now under the macro lens here, you can see how those two clearance angles meet at the corner, but we've left the entire cutting surface intact. Now here's where the magic happens. So we're back to where we started on our micrometer, and you can see we're right on the end clearance there. If we loosen this guy now and go back to the straight on position, we should also be right on our cutting edge. And now watch what's going to happen. I can loosen that joint. Now we can swing this guy around, and it's going to make our nose radius. And because we've clearanced down here on the end and we've clearanced over here on the side, all the wheel is going to be grinding is just the top there, and then a little bit of a radius on that corner there where the end relief and the side relief meet. We're just going to make that radius right there. So for this operation, you want to lock it again, because all we're going to be doing is swinging. Okay, so now here's our 40 thou radius gauge, and there is our 40 thou nose radius. So you can see that our offset of 85 on that vernier scale gave us the nose radius of 40 thou that we wanted. The last angle we need to make is this angle right here. So we clearance to the end on the back, but now we need to clearance it in this direction. So we need, like, I don't know, a 10-degree angle, something like that. This isn't super critical, just enough so that this, again, isn't going to rub. Now, this operation is probably where all of the various D-bit grinder manuals and users differ the most. Frankly, you can just freehand that little angle on the wheel, but I'll show you a way to do it precisely in case you want to. So we're going to square this guy up again, back to 0. Then we're going to go over to this joint here that swings the nose radius normally, and we're going to set it to 10 degrees in that direction. And now when we come up against the wheel, you can see that we're 10 degrees off this way, but this right here is our nose radius, so we're 10 degrees the wrong way. Now, some D-bit grinders will let you rotate this portion of the head past 90 by a few degrees for exactly this purpose. This particular grinder does not. However, the reason that we squared up that main clearance joint is so that we can do this. Flip that guy around 180 degrees, lock it in that position. Now we're grinding it upside down, but now the nose radius that does the cutting is back here. And so now our angle is falling away from the nose radius just like we want. And here's our final, a lovely little single flute end mill. I hope you can see all the different angles and clearances and radii that we put in there and how they all interrelate. So let's make some chips with this guy. Speeds and feeds with these guys are pretty simple. You just run them balls out. RPM pretty much as high as you can go, and maybe feed them a little slower than you would with something like a 4 flute, because you've got, 1/4 as many edges. And you got to go a little easy on the depth of cut. These are going to start to complain somewhere around 10 thou in steel and maybe 15 or 20 in aluminum, depending on the diameter of the cutter. Now here's where the D-bit really shines, if you will, and that's surface finish. This upper area here you can see was done with a conventional cutter, and you can see that the reflection of the numbers on the scale is sort of visible, but not really. And then down on the D-bit cut you can see how it's just like a mirror. Those numbers come through perfectly. And then here on the macro shot you can see our nice precise corner radius there. This cut isn't very deep, so the radius is not super easy to see there, but I hope this at least gives you a taste of what's possible with D-bits, and we've just scratched the surface on this amazing machine. But thank you very much for watching, and we'll see you next time.